In this module, we're going to use Stata to conduct a two-sample t-test. We're going to do this for two examples. We're going to do it for paired data. We're also going to do a t-test with independent data. So in our first example, we're going to use the Framingham cohort, and we want to test whether there is a difference in the mean heart rate between exam 1 and exam 2. So now go to Stata and open up the heartrate.dta dataset. Now this dataset has 100 observations, only has 3 variables: heart rate at exam 1, heart rate at exam 2, and sex. Now these data, are they independent or are they dependent? Since heart rate is measured on the same person at exam 1 and exam 2, this would be an example of paired data. So we know we need to do a paired t-test. And before we get to that, we just want to take a look at the sample mean and sample standard deviation of heart rate at exam 1 and exam 2. So we can do this through the use of the summarize command. So we can see that at exam 1, the mean heart rate is 75.03, and at exam 2, the mean heart rate is 76.17. Standard deviations are about similar, and the ranges are about similar. So the next thing we want to do is we're going to generate a variable for the difference in heart rate between exam 1 and exam 2. So to do that, type in the following command. So the command we use is generate, and a new variable we're generating is difference in heart rate, HDiff, and it's just simply heart rate at exam 2 minus heart rate at exam 1. So now let's take a look at the histogram of this new variable. Type in the following command. So now we can see from the histogram that the data look roughly normal and roughly symmetric. So that's good. That's what we need for a t-test. For paired t-tests, we care whether the difference is normally distributed. And it seems like this assumption is met. So the next thing we want to do is we're actually going to perform a hypothesis test. Now before we do that, we should probably write down our null and alternative hypothesis. So our null hypothesis, H0, is simply that the mean at exam 2 minus the mean at exam 1 is equal to 0. And the alternative, we're going to do a two-sided test, is simply that it's not equal to 0. So that's our null and alternative hypothesis. And so now we're going to run a t-test. And so the command in Stata is just simply t-test. So type in the following command. So the command we used is t-test HDiff double equal sign. Remember to put the double equal sign, or Stata will give you an error, equals 0. And as you can see, now we get some summary statistics out of 100 observations. The mean difference was 1.14 with a standard error of 1.3. And so we can get our test statistic here. This t, our test statistic is 0.8481. And we have 99 degrees of freedom. So now since we're doing a two-sided test, we're going to look at this middle column here for our p-value. So our p-value is 0.3984. And if we were doing a one-sided test, we would either look on this side or this side, depending on the direction of our alternative. But here we can see that our alternative is that the mean is not equal to 0. And that's what we want, that the mean difference is not equal to 0. So our p-value is 0.3984. So now what do we conclude with this result? With this result, we fail to reject the null hypothesis. And if you remember, the null hypothesis was that the difference was equal to 0. So we have no evidence that the difference in heart rate at exam 1 and exam 2 is different from 0. We have no evidence to say that's different from 0. Note, however, that's different from saying that they're equal. We can't conclude that the heart rates are equal. We just don't have enough evidence to say that they're not equal. And those two are different interpretations. Now instead of using the t-test HDiff double equal sign 0 command, you could have also used this following command. You could have used t-test heart rate 2 double equal sign heart rate 1. And as you'll see, you'll get the exact same test, the exact same p-value. The only difference is the syntax. And the only difference is we create a new variable called hdiff, while this t-test doesn't require you to create a new variable. It's preference of which way you prefer. I prefer to generate the differences because then we can look at, say for instance, a histogram of the differences, and we can test whether or not, or we can at least examine whether or not they're normally distributed. So I prefer to use the hdiff method. So for our next example, we're interested in whether the mean heart rate differs between men and women at exam 2. Now this is clearly a case where the observations are independent, so we would use a two-sample t-test with independent data. Now before we run the t-test, let's calculate the sample mean and sample standard deviation of heart rate at exam 2 for men and women separately. So we can do this through the use of the BySort command. So type in the following command. So if you type in the command BySort sex1: summarize heart rate 2, we'll get the summary statistics by sex for heart rate 2. As you can see, for men the mean is 76.8, and for females the mean is 75.7. Standard deviations are a little different, ranges are a little different, but close enough. They're similar. So now we want to perform a hypothesis test, and before we do that we should write down what are our null and what are our alternative hypothesis. So the null here in this case, simply that the mean of heart rate for males is equal to the mean heart rate for females. And the alternative, we're going to use a two-sided alternative here. We're just going to say that they're not equal. And so now that's our null and that's our alternative hypothesis. And now we're going to run the test in Stata. So type in the following command in Stata. So the command is t-test heart rate 2, which is our variable that we're interested in testing, by sex1, that's sort of our grouping variable, and we're going to assume unequal variances for this example. Now Stata by default will assume equal variances, so you have to tell it unequal, and it will calculate, and it will use the unequal formula. Now hit enter, and Stata gives us the relevant output. We can see that our test statistic is 0.4032, and our degrees of freedom are 82.8637. Now with unequal variances, we know that the distribution of the test statistic is not exactly a t-distribution, so we sort of have to approximate it with a t-distribution. And that's why we get these funky degrees of freedom, because we have to approximate this distribution. So once again, we're looking at a two-sided alternative. So we look here in the middle. Our alternative is that the difference is not equal to 0, and that's a two-sided alternative. And we can see that our p-value is 0.6879. So if we're testing at the alpha equals 0.05, we would fail to reject the null hypothesis. And so we would fail to reject the null hypothesis, and the null hypothesis is that the mean heart rate for men is equal to the mean heart rate for women. So we have no evidence to say that the mean heart rate for men is different from the mean heart rate for women. So next, let's take a look at this difference column, this difference row, excuse me. And let's look at a 95% confidence interval. Now we could rewrite our null hypothesis as such, that U of males minus U of females equals 0. And our alternative would just be that that difference is not equal to 0. So we can see here that our 95% confidence interval for that difference, mu m minus mu f, is negative 4.2 to 6.3. So that interval includes the number 0. And so if we were only given this 95% confidence interval, then we would know that at the alpha equals 0.05 level, that this hypothesis test would fail to reject, because that interval includes 0. So there's a one-to-one correspondence between this confidence interval and our decision to reject or accept the null hypothesis. So for instance, if this 95% confidence interval did not include 0, without even seeing a p-value, I could tell you that the t-test for this difference, the p-value will be less than 0.05. So there is a one-to-one correspondence between confidence intervals and hypothesis testing. So let's say instead of having heart rate in one variable and then sex in one variable, we have heart rate for women in one variable and heart rate for men in the other variable. Now how would we perform a t-test then? So we could use the following command. Okay, now this variable here, heart rate W, that's our heart rate for women, and that's one variable. And then heart rate M, that's our heart rate for men. And then we have to tell it, Stata will by default do a paired t-test, so we have to tell it this is unpaired, we want to do an independent t-test. And once again, we want unequal variances. So this is how you perform a t-test if you had heart rate for men in one column and heart rate for women in the other column. And remember to use that unpaired option, otherwise Stata will perform a paired t-test, which is what we don't want in this case. And that's all for this tutorial.